How are you?
Morning, Mr. President.
Good to see you.
Ken Wolf, RedZone Robotics.
Glad to see you.
Mr. President, Sue, well, please.
Good to see you.
Good to see you.
Sam, good. What do we got here?
We've got very important, great stuff here, Mr. President.
Fantastic.
RedZone is a successful CMU spin-out. We're a going concern. We maintain ties with the university through their green lighting startups initiative, and our sole purpose is to help save our nation's failing wastewater infrastructure. You mentioned the other day in your address the need to be a little bit more pragmatic at home and focus on things like infrastructure, and that's exactly what we do with sewer pipes, because our sewers are aging faster than we can keep up with them. You know, the failures are really bad for everybody, and the cities that we've worked with see great benefit. They not only save money, but they take the limited funds that they have and they spend them more wisely so they can extend that useful life of these assets. They have an easier time complying with federal and state regulators. They do a better job of delivering the services that are required of them, and then ultimately they do a better job protecting the environment. And the other good thing about when we get involved with these practical innovations, Mr. President, is they create jobs. Jobs are created for deploying these robots, so they can be deployed by city workers, union workers, untrained labor.
So let's just make sure we know what we're looking at. This is our guy who we're going to send into the sewer pipes.
This is an autonomous robot that's going to go into sewer pipes, make
He's
decisions.
going to be able to check in terms of, I don't know if I should call him he. I mean, I don't know if he has a name.
That one is named
Wally or
That's
whatever.
okay.
But he's going to be able to check leaks,
Yeah. So
stress.
what's great about what we're doing here, Mr. President, is this is the first commercially available field deployed autonomous robot, and we believe that sewer pipes are the perfect arena for expanding the use of autonomous robots because they adhere to the 3 Ds of robotics. They say if it's dirty, dangerous, and dull, you should seek to automate manual tasks, and that is the definition of a sewer pipe.
Right.
So yeah, these pipes go in. Robots go into pipes that we want to keep people out of, that we need to get good information on quickly, so that again, informed decisions can be made in terms of spending the limited funds that are available.
Right.
So they have cameras that build maps. Go ahead, sir.
Yeah, so essentially we're looking for defects in the pipe as we're going through. So this really is the first commercial, field deployable autonomous robot. So essentially we've made it extremely easy to deploy, that we can train our municipal workforce in a couple of hours to be able to deploy this. So typically this is a mock-up of a sewer pipe, and typically what you don't see this, you see the manhole lids, and this is what is at the bottom of it. So then the municipal worker put a robot in there, go to setup job, pick up a couple of parameters.
And is this
here.
the unit that he's going to be working on?
Yeah, so essentially the entire package is 4 robots in one laptop. So essentially that's what he's going to the field with. Once he drops it in, he selects a couple of parameters, hits finish, and it's going to send all the data back to the robot. And the robot right now is also looking for a GPS status, so it's going to get a GPS log so that we can take it back to the map. So once it gets that, it's actually ready for deployment. If you would like to, you can hit the launch button right here.
Come on, let's launch this guy. What's his name again?
Ned.
Ned. Let's see how Ned does.
So from here, he's going to basically take off, and all remote operation is done. It's fully autonomous. He's tightening up his line so that's how he determines how far he is in the pipe. And from here, it's going to use his onboard intelligence and onboard sensing to basically navigate the entire pipe. And as it's going through, it's getting high definition digital images and other sensors. And once it gets to the end of the pipe, which typically would be 300-400 feet away, it's going to detect that and come back to the start manhole.
And he's sending back data as he's going through?
Right now, he's storing everything on board.
Storing it?
Yeah. Once he comes back to the hole, he'll again start talking to the remote, and then we'll get all that information back. So right there, he's going to come back, and essentially once he's back at the hole, we'll talk to him. Because it's fully autonomous, the municipal worker that deployed this, once this is going, can go deploy more robots, and that's how we get force multiplication. So essentially, we're increasing his productivity by 3-4 times, and that's with a higher quality as well. So with this, we're helping cities to essentially inspect their entire network in a fraction
Hold on
of
a
the
second.
time.
Now, before the pool goes, this is pretty cool, right? Don't you think? Now, the part of what is fascinating about this is you're seeing private companies co-locating inside Carnegie Mellon, so that the research that's being done goes much more quickly into application. And as they construct, using these new technologies, actual products that can be used, that actually feeds back into the research, because you're discovering problems all the time, and folks here can collaborate with you in terms of trying to solve those problems, and it creates new research problems for folks to work on.
And it's government-funded research, which is making an impact.
Government-funded research resulting in new products, new companies, new jobs.
Yep. So once the robot comes back, they'll quickly take a look at the inspection that it just did, and here I can